we're going to try to get this thing moving. So before we start, my name is Tim Meister. I am the East Central Regional Rep for the Illinois Fire Service Institute. That is my part-time job. My full-time job, I'm an assistant fire chief down here in Charleston, Illinois. We're going to talk about rural water supply, and the good thing, I'm not your guy, but I've got a guy that can talk about this because he does it all the time. So a couple things before we get started. I'll lay down the ground rules for you. You're going to notice that we are using the Zoom webinar feature. We have got the chat feature shut down on this. So with that being said, if you have a question, down at the bottom of your screen, the Q&A, please give us a question. As Bill is going on through this process, type it in there. We'll try to answer it as soon as possible. We'll make sure all the questions get answered before we get off here today, as long as the Zoom platform allows us to. So this class is available for certification of attendance. So if everybody registered via the website and you put in your full name and all your information, give us about 14 days, then you'll notice in the Student Center, there will be a certificate of attendance. You must attend the entire class to get the certificate of attendance, okay? If you are signed in via iPad or another tablet or some kind of device, please give us your full name. Okay, sometimes we see iPad number 5, iPad number 7, or Phil or Bill. In order to get a certificate of attendance, we need your full name. Okay, if you are watching this with your department, with a number of personnel, number of firefighters, please have your training officer or fire chief give us a roster. Send it into the Institute, and with everybody's full name, along with their signature, the date, and what class you guys attended as a group, and ladies, and we will try to get you a certificate of attendance that way. All right. If there's any questions regarding your certificate, please email fsi-elearning@illinois.edu. Once again, fsi-elearning@illinois.edu. They'll be able to answer any questions for you, try to get you squared away on your certificate. Okay. Just so you know, we have multiple virtual classes coming up. If you take a look at the IFSI website, you'll notice it right there on our front page. Click on that, and there's more classes to come. We're not sure how this shutdown is going to affect us too much, so we're just going to keep going with this and trying to get firefighters trained. So the next class we have coming up, Fireground Search and Rescue, and that class is going to be held on Monday, June 8th from 6 to 8, and they will do the same class on Saturday, June 13th at 10 o'clock in the morning to 12 o'clock. So it should be a good class. I know the Central Region is taking care of that, so they got a couple good instructors lined up, so it should be a very good informative class. So if you have any questions for IFSI, the phone number for you to call would be 217-333-3800. And I believe everybody should know our website is www.fsi.illinois.edu. You're going to find the most up-to-date information there. So you should have received one more thing for you. You should have received an email for the course evaluation form. Please fill that out. Give us anything you didn't like. Give us things you like, things we need to change, other things you want to see. We try to adjust how our classes are going to go depending on what response we get from you. So please fill those out, and we'll try to make this as best as possible. So that's enough of me rambling. Okay, so now I'm going to turn it over to the expert. Bill Fulton is going to be your instructor today from Salem. I'll let him go into a little bio on him, and we'll turn it over to you, Bill.
Okay, sounds good, Tim. Thank you. Get things set up here. Okay, well, we're going to talk about rural water supply today. That's the name of the class. We'll talk a little bit about some name changes that we're in the process of doing. But as Tim said, my name's Bill Fulton. I'm the District Fire Marshal at Salem Fire Protection District. I've been there 24 years. Our district is about 124 square miles. A lot of it is rural. We do have some oil production in our area, so we're kind of versed on that too. I've been an IFSI instructor for about 16 years. Started out in hazardous materials, but I primarily teach now in the Ag Rescue program, grain bin rescue, ag rescue, responding to anhydrous ammonia emergencies, that kind of thing. Along with that, I also teach the basic pumps class, oil well firefighting, and the rural engine and tender ops, which class has kind of evolved from that class. Like I said, the class that you signed up for today was called Rural Water Supply. We have, because of some work of some folks early this spring, it has been renamed Mobile Water Supply Operations because it doesn't just happen in rural areas. I'd like to kind of thank those folks, John, Ashley, and Tal. They did a lot of work on this program, kind of upgraded it. And the other thing that they did is they divided out the driving portion. And the driving portion will be a class on its own under the Cornerstone program. So you might look for that coming down the pike here for long. We're going to talk mainly about efficiently moving water. And then, like I say, the driving class will basically look at all of the aspects of actually driving the apparatus. So let's get into it. Mobile water supply operations. You're going to hear this a lot today, efficiency. Efficiency is the key to successful operations. We want to minimize that wasted time when we're trying to move that water and get the most water we possibly can, maximize that water delivery rate. We want to be efficient, and the way we do that is we do a lot of planning. You're going to hear a lot of things about pre-planning. When we pre-plan, we look at what could happen, so then we have to train on it. And we'll talk some about what we can do as far as training, some joint training, that kind of thing. And the other thing we have to do is we have to test what we think is going to happen when we follow our planning, follow our pre-planning. When I was doing some research the other day, I did come across this statement, which I really liked. It came from a piece of work from Steamboat Springs Rural Fire Protection District out in Colorado. It says water supply in a fire suppression operation is necessary not only for the property protection, but also most importantly for the safety of the occupants and the safety of the firefighters. And I think that means a whole lot. We usually think, how big is the building? What's it going to take to put that out? But the other thing we got to look at is the safety of the people that were involved with that structure, and also the firefighters themselves. When we look at a mobile water supply, we have to look at our water sources that we have available. Where are we going to get this water once those tenders are empty? It has to be adequate to meet the fire ground needs that we have. So again, we have to pre-plan, look at our fire load in our response area, and look at those static water sources, which include ponds, lakes, rivers, streams, whatever we can utilize for a water supply, or municipalities, what kind of systems that they have, what kind of rural water districts do we have, what kind of hydrants do they have, can we use those hydrants? Some of the rural water districts don't feel, there's been some restrictions on how we can use some of the hydrants as far as actually hooking onto them versus free flowing them into a portable tank. And we'll talk about that in just a little bit, but that's what we're looking at. Those are our two main sources, the static and the municipal water systems. When we look at a municipal water system, it's a combination of water towers and pumps and that kind of thing. And we have to determine what kind of flow we can get from those systems. Is it something that that is on a pump system completely with no towers, which I've seen that? Or is it a system where they have, just a regular low volume pump that continuously is refilling the tank until that tank is full, then it shuts off, or they do shut it off. And it could be I know in one particular district that that we provide some mutual aid assistance to. If they have a structure fire in the village, that's a true working structure fire, one of the things they have to do is call and get those pumps turned on as quickly as possible, because the tank is sufficient to supply that village with a normal volume of water. But when we talk about fire suppression, it normally can't keep up. The pressure is provided by either the pumps, if it's on a continuous pumping system, or by the elevation of the water towers that they have. And you can have multiple water towers in any different water system. Then the other thing you have to look at is what kind of volume you have, the storage, the water towers or tanks that they have available to us. As far as water towers, that just provides that buffer between the pumps. You know, like I said, a lot of them are, the pumps are low volume pumps, but they continuously can keep that water tank topped off. But we get into a rather large structure fire, it's very possible that water tower can't keep up with the volume that we're using. So we have to look for a different source. The thing that we have to look at is how quickly can they refill? And the other thing we have to be concerned about is if we utilize a large volume of that water, are we putting that water system at a situation where they may have to go into a boil order? Because when we lower those pressures, lower that volume in those tanks, there's a possibility they'd have to go into a boil order before they, as those tanks refill. Static sources, you know, we have to look at accessibility. Can we get close enough to that water source to actually access it, to use it to pump, set a pumper there and draw off of that system? You know, it's got to be stable, and this is very weather dependent. You know, it could be in the middle of the winter and you could have 8 or 10 inches of snow on the ground and it be not accessible. You could have a situation where you've got possibly soft ground, early spring, or lots of rain like we've had here lately, actually, where you can't, you know, you've only going to carry about 20 foot of that hard section, and we have to get it out into that water, whether it be a stream, pond, lake, whatever. And we have to have at least 2 foot of water around that strainer to successfully draft. So we've got to look at those situations. Now you can see here the picture on your right. That's really not too bad of a place to pull up there to that dry hydrant and get to the edge there. So, but again, it could get soft. A lot of fire districts use dry hydrants. It allows for better accessibility. We don't have to worry quite as much about getting that hard section out into the actual body of water. The thing we want to look at here, now just for instance here, this is in my district, and this would be, I think, a good example of a place where we can get close to the water's edge. This is the old Centralia Lake Reservoir. They used to use it as a water source. They no longer do. It's strictly used as a recreational area now, but they have a very nice, you can see on the left side here, you've got a very nice boat dock to pull up to set up a drafting operation. And the other thing that's very nice about this particular area to draft is the parking lot. It's set up where we can actually bring those tenders in. They don't have to back in to be filled. They can make a circle drive there and go right on back to the fire scene. The other thing about the dry hydrants, in this picture here, you're seeing these guys, this is actually a dry hydrant in my fire district, but neighboring district, Kinmundy Alma, is actually exercising that hydrant. They're using a drill night and they're doing some testing on flow. They're making sure that dry hydrant is serviceable and so forth. They're kind of checking out how they would use it. And that's another, you know, I said something earlier about the training. That's the thing you've got to do. Not only do you have to know where they're at and know that they're there and they're accessible, but you have to actually train on them and make sure that they function with the equipment that you've got. As far as water quality, you know, it doesn't have to be drinking quality water. It just has to be free of debris. We don't want to get into a situation where we're using water that's got a lot of debris in it, whether it be sludge or something out of a lake or a pond. Or I know I always use the example I heard a few years ago about a major fire up north central Illinois where they were drawing water off of a river and inadvertently got too low in the riverbed and pulled sand in through the pump. And you can only imagine what that does to the impellers on a pump to be pumping sand in there with that water that you're drawing in. So we've got to be cautious about that. That's the main thing about the water quality, is to make sure that it's just free of debris. As far as quantity, we have to look at this. What can we really get? Now on dry hydrants, ISO suggests that you have to have a sustained 250 gallon per minute flow for 2 hours for it to be a viable dry hydrant. And for the most part, any lake or pond that you would put these in, that's not a problem. So when you look at dry hydrants, that's kind of another thing that you can test. You don't have to flow them for 2 hours, but you can at least flow them for a while and put a stopwatch on it and see what kind of flow you can get out of it. Okay, as far as the water supply operation, one of the things that's very vital to a water supply operation is communications. We strongly suggest you dedicate a radio channel for water supply operations. It keeps it off of the fireground channel. We don't have a lot of chatter from either one. There's no confusion as to who's talking to who, that kind of thing. And one of the things that I've been a proponent of, if you're on the MABUS system, if you have the MABUS channels in your radio system, is using MABUS Blue as the radio channel for water. People associate blue with water, and it's fairly easy to remember which one you've got to switch to for your water supply operation. You know, I know guys who can drive tenders. They could thread them through the eye of a needle, but when it comes to remembering which radio channel that we're going to use for water supply, you know, if it's channel 4 or whatever, they don't, you know, it's just, that's not their thing. But they remember MABUS Blue when it comes to switching over if they're in that tender. The other thing we've got to have, I think, is a water supply officer. This keeps order in that operation. They're in charge of the entire water supply operation. They're in constant communication with the IC as far as determining what they need. And the other thing that they do is they reassess the incident's water supply needs constantly and make sure that they're getting enough water to that scene. When we look at a water supply officer, some of the things that is very important for them to be able to do, it adds order to that water shuttle. Typically, I like to see them at the dump point, and they're kind of controlling things from that dump point, because that way they can kind of see the amount of water going out from the dump tanks and see what the status is on the particular fire incident that you're dealing with. They maintain an adequate and continuous flow of water. And here again, this is where they're kind of monitoring to see how that, you know, if we're keeping up or not keeping up, that kind of thing. That's why it's important for them to be there at that dump site. They take the added pressure off the IC. Hopefully, if they're doing their job, the IC never has to worry about water flow. And that's important for those water supply officers. When we do this as a class, typically what I will do in the practicals is I will assign different people, different officers within they're at the class to be the water supply officer. So they get a feel for that. And a lot of times we'll kind of throw a scenario at them where we're actually running out of water. What are they going to do there and that kind of thing. They direct the traffic both in and out, because you may have multiple fill sites. And if they see something works better to send a particular tender to a hydrant versus to the pumper that's sitting at a lake, they may change that up, you know, and that's just the different things that a water supply officer should be in charge of. Now they have to have the authority to add or subtract water tenders. If they're not keeping up and they feel like they need to have another district called in or another fire department called in with a tender, they need to have that authority from the IC to do that on their own, not have to ask him to do it, but do it on their own. The other thing they have to have is the authority to add a fill point. A few years ago, we had a small convenience store on fire in a neighboring district over here. And I happened to be the water supply officer that night. We were looking at, just down the road, there was a small rural grade school with a circle drive, with a steamer hydrant right in the middle of that circle drive. It was probably 3/8 of a mile from the actual fire incident. So what would be a better fill point? So we were sending tenders down there. And then all of a sudden I get tenders coming back and they're saying it's taking us 7 minutes to fill a 2,000-gallon tender. That wasn't working. Well, we had a water tower a 1.75 miles away with a steamer hydrant at the base of it. And so we added that fill point along with the one at the circle drive at the grade school, and we're able to keep up that way. And a lot of times the tenders going to the fill point at the bottom of the water tower were actually lapping the group that was going down to the grade school. But that's just this kind of things that you find, and that's why we have to have the authority to add those fill points as needed to make sure that we have that adequate water supply. Now, if we have enough personnel, you know, and I know everybody can be sometimes shorthanded at some of these scenes, but it's good to have a fill site officer and a dump site officer. You know, the fill site officer obviously supervises everything that's going on at a particular fill site. They ensure that the water source will meet the demand that that we need for those tenders coming in there, and that they establish that pattern, hopefully a pattern where we don't have to back up to refill those tenders and that kind of thing. If we can have a dump site officer, and that dump site officer may take some of the pressure actually off of the water supply officer, because he's going to direct traffic in and out of the dump site. He's going to possibly even see the need to send a particular tender to the other fill site if he thinks they'll fill quicker there and that kind of thing. So if we have the personnel, these are people that, these are slots that we can fill and just add to that efficiency. Just some observations as far as things you can see as a dump site or fill site officer, or as a water supply officer. You know, if the tenders are waiting to dump, maybe we need to put more dump tanks down, multiple dump tanks if we're only using one, or maybe put a third one in if we're using two, that kind of thing, so that we can get them dumped, get them back on the road, get them filled. We need more dump point access. You know, maybe we need to set things up a little different, that kind of thing. Maybe we've got tenders that only can back in. Maybe we've got tenders that dump from the side only, that kind of thing. You know, we can see that we've got, we're actually bringing in more water than they're using on the fire scene. If that's the case, then we can tell a IC, hey, you can drop a couple of more lines if you want to. You know, we've got adequate flow. Let's, you know, if you need it, it's here to be used. If we've got tenders waiting at the fill site, then we probably need to add another fill point. Or if we've got, let's say we're sitting at a pond or a lake or something like that, maybe we need to add a second engine to the fill site where we can fill multiple tenders at one time. If we have no tenders waiting to fill or at the dump site, maybe this is where we need to add more, that we're just not keeping up. We need to add more, ask for more mutual aid and that kind of thing. As far as the operation, you know, there's three major components. It's the fill site, the tenders themselves, and then the dump site. Now, the one thing I want you to look at as for this diagram over here on the right-hand side, you know, it's showing the three different components, but the thing I want you to notice more than anything there is the tenders never meet. If the water supply officer can work it out, that's the safest, best way for things to happen. If we can loop around where we never have to, an empty tender never has to meet a full tender, so much the better. It becomes a safety issue, and it just becomes, makes it so much easier to operate when you don't have to meet those tenders coming and going. So let's take a look at fill site.
Hey, Bill, I got a question for you before
Sure.
you get going on the fill site.
Sure.
Miss Laura has a question. How do you determine how many gallons per minute you are drafting from a tank? And then how many gallons per minute are you putting into the pumper you're supplying? So she's wanting to know how can you tell how many gallons you're bringing in from your fill site, and how can you tell how many gallons you're putting out?
Well, typically, okay, let me think about that.
Okay.
There are times that you can actually chart that. Some water, if you're on a rather large incident, a lot of times they will actually have a clipboard with you know, a legal pad or whatever, and they will write down how many times those tenders dump as they come through. And now as far as flow out, I mean, your attack pumper is only going to use so much, or if you've got multiple attack pumpers, or let's say you've got an aerial in use, that's a little different story. But you can record that to know. Now, if they're wanting to know,
So Bill, I think
in the process, I'm not sure that you can necessarily, you know how much you've dumped and you know what's going out. I'm not sure. Maybe I'm not answering the question properly.
I feel like when you get down to the formulas later in the PowerPoint,
Yeah.
it might explain a little bit more but I feel like everything would come back down to your pump capacity and how much you can put out.
Right. Yeah. I mean,
So-
that's your attack pumper's going to be the basis for how much is going out. Definitely. I mean, it's only going to supply so much. Or if, like I say, if you got multiple areas where you've got different attack pumpers, or let's say you've got an aerial in operation and so forth, that could be you know, again, add to the amount of water going out. I'm not sure about the, I mean, as far as coming in, now, I guess the rule of thumb is for every tender that you've got on the road, you should be able to get 100 gallons per minute flow.
There we go. I think that's what she was looking for.
Okay. All right.
And
What at the fire scene, and that's a little later in the slides, but at the fire scene, for every tender that you've got on the road supplying water in a mobile water situation, you should be able to get 100 gallons per minute flow. So and we'll go through some of the formulas as far as the size of the building and that kind of thing a little later. But you know, if you're looking at having to have a 250 or 300 gallon flow, you need to have 3 tenders on the road bringing you water. I mean, it's that simple. Right? Sometimes you'll get more. The newer tenders have better venting. They have better options as far as the dump capacity and that kind of thing. I know I did a class one day where the guys had a new tender, and one of the things that they wanted to try, which I said, fine, is we set the tanks up in a diamond situation, and they literally set up where they could dump from the back and the front, and they dumped in 35 seconds. Had dumped a 2,500 gallon tender. So, you know, the newer ones definitely have the capacity to dump quickly. So, but like I say, normally what the rule of thumb is 100 gallons per tender that we have in the operation. So we'll look at that a little bit later in the formulas too. Okay, as far as the fill site, you know, the location has to be a suitable water source. You don't want to just, you know, you don't want to pick some small pond or something like that. You want to have a water source that, and hopefully you've pre-planned this and identified it early, as opposed to, well, now where are we going to go? I will say this, we need to know our response area, obviously, but we need to know where some of these lakes, ponds, streams, that kind of thing are. Because I know I have been on scenes where, you know, you get the call at 1 o'clock in the morning and you're hauling water from 3 miles away for 3 hours, and all of a sudden the sun starts to come up, and right over the hill was a pond that you could have used and nobody knew about it or nobody asked about it. And here again, if you're out, let's say you're out on a In a rural area, ask the owner real quick, do you have a pond, a lake, somewhere where we can draw water? But the biggest thing is in pre-planning is look at these places, make sure that we've got them documented. As far as municipal systems, we need to look at hydrants with high flow and utilize those first as opposed to some of the others, and preferably close to a water tower. And the other thing that with the static sources, we have to consider those static sources with all weather conditions. You can't just say, well, that's going to be really nice in September, because it could be in July. Maybe it's a water source for a livestock operation, and because of no rain, it's been drawn down pretty well in July. Or it's something that in the middle of the winter, it's not accessible because it's either too wet or there's too much snow on the ground or whatever. This is why we need to plan on multiple fill sites if possible. I threw in a slide. This is just some fill sites in my response area. And I'm going to kind of go through these to get, just to give you an idea of why we pick what we pick. The one up here on the upper left side, this is a green hydrant as far as flow. The thing that's unique about this, you can see the asphalt parking lot sitting there. It's at a local distributor for propane. So even in the wintertime, that parking lot is clear and clean because they have to have access to the buildings and be able to get in and out. So it's usually a clean parking lot. So that makes it a good place for a fill site. The one in the upper right-hand side over here, this is one of the ones I was talking about earlier. This is at the bottom of a water tower, steamer hydrant. The other thing that's unique about this is where they have a water vending operation. There's a circle drive there where they can pull up and you can buy water from the district. So it's got a good driveway, good roadway right there where you can make a big circle. The one down here in the lower right-hand side, this is a blue hydrant. This is at the USDA service office in Salem. It's a big concrete parking lot. They usually keep it clean year round. And it's got a big wide driveway in and one out so that you can have bring tenders in. They don't have to back in to be filled and all that kind of thing. So it would work really well. The one in the lower left side here, again, is a good green hydrant. This happens to be out on a good state highway, nice circle drive there. The other thing the guys sometimes like there too is this is at the ice cream shop, so the guys that are filling tenders can slip away sometimes and get some ice cream. So they kind of like that. Bring this hydrant up too. This hydrant, you can see, kind of looks like it's just kind of out in the farm field, kind of, that road's not, it's kind of a mud road back to it, but it's not too far off of the main road. The main road looks like this right here. This is the end of the road that runs right beside it. You wouldn't really think about this being a hydrant that you'd want to use or whatever, but what you don't realize is, if you don't pre-plan it and understand it, is this is on a main line to the industrial park, which is a 10 or a 12-inch line, and is an extremely good source of water on a really nice road. So this makes a super place to fill tenders. But the key to this is not only do you have to know where it's at in your district, but your mutual aid or automatic aid departments need to know where this is at. So if you set up this fill point, they know. Now, one of the things that we discussed Tuesday night when we were looking at this is it could be a good thing to map these and then add those maps to your tenders, to your engines, and also possibly get the mutual aid departments involved and give those maps to them also, so that there's no confusion as to where they're going if you tell them to go to a certain hydrant or a certain boat dock, that kind of thing. Here we go. As far as fill site, our goal is to fill 1,000 gallons per minute with no waiting. We want to connect up to multiple tenders if at all possible. We only fill one at a time. We don't want to, you know, it actually, you'll find that it's wasted time to try to fill two tenders at the same time, even though it's better to connect them up, but only fill one at a time and get them on, moving on down the road. We want to do this with limited maneuvering. Hopefully we don't have to back up to fill them. Hopefully we got it in some kind of a circle drive situation. As far as municipal water sources, you know, we can fill directly off the hydrant, but one of the things, Denny Wilson did some work at Fire College a few years ago. Denny did a lot of work with rural water and so forth. And I know one of the studies that he did during the class came up at 50% increase in flow if we put a pumper on that hydrant. Now, some rural water districts do not like for you to hook up and draw water off their system with a pumper. So in that case, what we would do is we would hook up a diffuser or J-tube and let it free flow into a dump tank and then draft off of it. You know, we cooperate with those folks, and that's the way we would want to do that. The other place I've seen this work well too is if you've got a hydrant that is at the end of a line and it's a basically a flush hydrant, you can still do the same thing. You can throw down a dump tank and just hook up a J-tube or a diffuser and let it continuously fill that dump tank and just draw off of it that away. Otherwise, you wouldn't be able to use it. Now, when we fill from a static source, one of the things that we can also use is we can use floating pumps or portable pumps and do the same thing. We can have those dump into a dump tank and then draft off of those and fill those tenders that way, especially if we've got multiple tenders working at the same. It gives you a little advantage of getting out into the, getting closer to the side of the static source, and it gives you the advantage of being able to go ahead and use those pumpers there at the scene, at the fill point scene, I'm sorry. Anyway, as far as dry hydrants, we have to have good access to those, it gives us good access to the water source. You can see here how those are set up here in this lower diagram right here. They need to be maintained though, and this is something that we can do in training. We can flush them out and utilize them and test them and all that kind of thing in training. So if we do happen to need those, we can, they're already flushed. We already know what their capacities are and that kind of thing if the need arises from an incident. You can see the strainer down here at the bottom. There's all kinds of different ways that they hook those strainers up. Some of the older ones, all they did was cap that into that pipe and then drill holes into the tubing to draw that water in. Some of the people have come up with some better ideas, such as there's actually a strainer out there that has a flapper on the end of it, so that if you are flushing it and cleaning it out, that flapper opens up and gets all the debris out the very end, and then it's on a spring and springs back shut. And that way you're not drawing any large things in there and so forth, but it does allow you to get any kind of sediment and so forth out of there very quickly. You know, I say it's across the board what you can do with those strainers, whether you buy a commercial one or whether you develop those on your own. I will say, through some research that I did the other night, there are some grants out there for dry hydrants. It's a 50-50 grant from the Illinois Department of Natural Resources. And from what I understand, if I read it correctly, and this would be up to the individual district to take a look at it, but they allow like $5,000 for setup of dry hydrants, which includes installation. Now, the thing about dry hydrants also is you're going to have to get permission from the private landowner if you set those up. But normally they're wanting those out there for their own fire protection. And even in a public water source, if you hook up a dry hydrant, you'll have to make sure that you have the legal right to set those up. But they are an extremely good resource for a fill point. When we set those up, we want to use 2 3-inch hose lines. 2.5 will work, but 3 inches is better. They're lighter to use than trying to maneuver LDH around. I'm not a big You know, I would rather use 2-3 inch lines as the LDH for those kind of situations. It's less likely to kink than the LDH and so forth. The other thing that's very important on this slide is we need to standardize those hose fittings on those, everybody that's we're using for mutual aid, automatic aid, and so forth. We can use cam locks, we can use Storz fittings, it doesn't matter. We just don't want to use threaded fittings because it takes so long to thread those on every time. It actually reduces it down to 1/3 of the time if we're using either cam locks or Storz fittings. Now, the thing you've got to do, I mean, everybody's got to be in agreement on this. This is one of those things that chiefs have to just sit down and say, here's what we're going to use and here's how we're going to do it. Now, I will caution you, if you're using cam lock fittings, to make sure everybody's on the same page when it comes to where the male and the female fitting are located, which is going to be on the tender, which is going to be on the hose line, because again, this only adds to the efficiency if everybody's got, let's say, the male on the tender, so that we don't have to build adapters at the seam of that fill site to adapt one tender over because they put the wrong fitting on there. One thing that alleviates that is if we go with Storz fittings, because they're neither male or female, and you know, you just can't really mess that up. You can hook up to it no matter what. One of the things that comes in real handy, especially if you're not using your tender as a tender, some people use pumper tenders and so forth, they're not set up as a tender the whole time, is to have a fill point box. This is our fill point box that goes on our pumper tankers. And, you know, it's got the quarter turn valve or it's got the gate valves, whichever you use. It's got some lights if we need for direction. It's got some fittings. It's got some wrenches and so forth in there. It's even got a little bit of plumber's tape in there if we're having some problems with leakage. So this is just something to set up ahead of time. The other thing that we do, and we found that works out very, very well, is we set up a couple of our brush trucks as with the tender equipment, including the 3-inch hose and that kind of thing. And if what we have is we have 6 companies. Our staff is divided up into 6 companies, with one company being what we call station crew every month. 5 companies go to the scene. 1 company comes to the station in case of a second call. So what that company would do in case we need a fill point is they would take the brush truck to the fill point and hopefully have it set up before the first tender goes in there for a refill. That also adds safety to the area because you've got a truck there constantly with a set of flashing lights. You know, if you're filling from a hydrant or something like that, and it, like I say, it just speeds up, makes it more efficient if it's already set up when the first tender pulls in there empty. Again, multiple sites. Maybe you want to, you know, maybe you're going to fill off of a hydrant, fill off a stream, and maybe off of a dry hydrant. You know, they're just multiple sites should be considered if you've got a large incident going. The main thing there is to just make sure everybody involved with the water supply operation knows where those fill sites are, and they're not having to go out and just try to locate them somewhere. Make sure that they know exactly where they're going when they leave the scene after they've dumped. The other thing I'll throw out there is this little truck and the big water it can supply. This little truck is over in a neighboring county, and I think it's just an ideal thing for mobile water supply. 4-wheel drive truck it's got a 2,000 gallon per minute high volume low pressure pump on it. It can fill a 3,300 gallon tender in 2.5 minutes. It can get right up to the water's edge really easy. You can see here in a couple of the side pictures how quickly it can get there. I just think it's a really good tool if you've got a situation where you're utilizing lakes, ponds, streams, that kind of thing, static water supplies. I just think it's an excellent tool to have in your toolbox for mobile water It just adds for efficiency because you're not having to get that big heavy pumper out there to draft with. You can draft with this, and it just works really well. Okay, when we go to this apparatus itself, you know, it's there to haul water. We're trying to get a continuous flow, and it has a lot to do with how quickly we can dump, how quickly we can refill, and how far we have to travel, what's the timing between the fill site and the dump site. When we look at this, a lot of times it depends on the apparatus. And, you know, this is the other thing, when you're pre-planning, you have to look at the neighboring districts or departments apparatus and just see what their capabilities are. And this is something we can do in training. We can invite these folks in and have a training night where we actually set up a mobile water operation. And this is where we get the stopwatch out. How quickly do they dump? How quickly can we get them refilled? And there's differences in refilling. I've seen at some of the classes where it made a difference when we were refilling, whether they're pushing water in the bottom or whether they've got a tube that pushes it over the top, as far as how quickly it'll refill at a hydrant. That's without a pumper. And here again, the rule of thumb is 100 gallons per minute per tender that we've got in that mobile operation. The thing that we've got to realize too is these are usually very large apparatus. They're probably one of the heaviest vehicles that we have in the fleet, and they handle differently. They handle differently whether they're loaded or whether they're empty. One of the things too that we have to watch out for is we need to make sure that we get those empty before they leave the dump site. We don't want any residual water in there if at all possible. You know, when we're looking at buying dump tanks, we want to buy dump tanks that are 10% larger than the tender that they're going to be used with, so that we can make sure and get those completely dumped before we head back. You know, that surge of that water has caused a lot of accidents, and statistically, you know, the second worst thing that kills firefighters is the apparatus accidents. And I looked that up through the NFPA this week. And again, it's still there, guys. And it's one of the things that can happen. And you can see, you know, the tender up here in the picture. They have a high center of gravity, and that liquid surge is a little bit strange to deal with sometimes. So we need to make sure they're empty and slow and steady and I don't mean slow, but I just mean a steady operation works much better than a very quick operation where we lose a tender.
Bill, I got a question for you.
Sure.
Came in from Greg. What is your decision-making process when to relay pump or to set up a portable tank, like a porta tank, when using tankers? Do you have a somewhat standard that you go by? Or?
Well, what I would look at is when he's talking about relay pumping, he's talking about just setting the tender there and draw. And yeah, if it's a room and contents fire, you know, that's one thing. If it's and it also, here again, we get back to the capacity of his pumper. Are we talking about a 500-gallon pumper sitting there on the scene and we're utilizing it, or at Salem, when we leave the station, our first due is a 2,000-gallon Class A pumper, and it's followed by our second due, which is a 2,000-gallon Class A pumper. So we take 4,000 gallons of water to the scene, whether it's the city or the rural, to begin with. So, but if it looks, it has to do with, you know, how involved it is and that kind of thing, or what we think we've got. And the other thing you have to look at is what's the occupancy? What are we, you know, what's the fire load and that kind of thing. If the percentage of involvement is, I would say, over 20-25%, I'm going to set up a water shuttle. no matter what. If it's, like I say, again, if it's just a room and contents fire or it hasn't gone too far, then we probably wouldn't need the water shuttle. But if we're dumping those tenders pretty quick, just pumping them off, that kind of thing, we probably need to get that mobile water. If you're using, well, rule of thumb is if you're using over 250 gallons per minute, you probably need to get some dump tanks down, or at least get a mobile water operation going.
So let me ask you this. If I relay pump, aren't I going to get more water? So everything would be dependent on the size of the fire and how much water we're going to need to put out that fire? Yeah,
absolutely.
Okay.
And that we're going to get into some figures here in a little bit as far as what kind of flows we need when we're pre-planning, and it kind of gives you an idea of what. Now, if they're talking about relay pumping from a hydrant that's just 2,000 feet down the road, and you're going to set up a relay pumper, that's a little different. They're still in the water loop theoretically, and it's kind of, if that's the case, if you're just a couple of thousand feet away from a hydrant and you can relay pump, it's kind of silly to load it, haul it, dump it, and that kind of thing. If that's what he's asking, no, I would relay pump in that kind of situation.
Okay, perfect. Thank you, Bill.
Okay, as far as a dump site, we want to get it located at, or at least as close as we can to the fire. That way we're not having, there's places where we might have to relay even from a dump site, but we hopefully we're using actually the attack engine to draft that water and put the water on the fire incident. Hopefully we can set up in some kind of an area like an intersection or a parking lot or whatever, where the tenders have access to dump and can get going back on the road again. Intersections work really well because we can get multiple tenders in there and unload them all at the same time, and we'll talk about the way we would set those up here in just a second. When we talk about deploying the tank, we want to set it in an area, and here's one of the things about mobile water when we're setting these portable tanks up. The first decisions that are made, the first 10 minutes of setting these things up are going to make your night really good or really bad, because if we don't get those tanks set up in the right spot, it's going to make every driver, every supply officer and everything's night pretty bad. So we want to keep them as level as possible, because if we don't keep them level, we're going to have spillage. And we don't want that. We don't want to waste water. We're trying to be efficient. And we want them to be easily accessible from multiple directions if we have those tenders coming in where they have to back in and dump off the back, or whether they can side dump. The thing that we want to look at when we're setting those up, we want to make sure that we position that drain on the downhill side, if there is a downhill side, so that when the incident is complete and we're picking things up, it's easy to get that residual water out of the bottom of that tank. We want to get a salvage cover down, and or a tarp of some sort underneath there, because a dump tank is basically a fitted tarp that's inside a frame, and there is movement of those when you're drafting off of there and so forth. It's vibrating, and if we've got, let's say, rocks, or we've got it on an asphalt surface or something like that, it can wear on that tank. So we put something underneath it to make sure that vibration doesn't cause wear and tear. The other thing we want to look at is we don't want, if we're using multiple tanks, we don't want to be dumping water right on top of the low level strainer. This causes turbulence. It causes problems with air in the pump that we're trying to draft with. So if we can set it up here where we're putting that water away from that low level strainer, like in this particular picture, it's just more efficient as far as delivering that water to the scene. The other thing that we want to look at, from time to time, we'll get water levels down to where we'll actually have a whirlpool develop in that tank. And one of the things you can carry is you can carry an old soccer ball, an old basketball, something like that, volleyball, and put that, just let it float in that tank that you're drafting off of, and it will actually find its way over the top of that whirlpool and seal that off so you're not drawing any air into the pump that way. Or I found that you can actually just float a piece of 1/2-inch plywood that's cut about 2 by 2 and float it in there, and it will seal over that whirlpool and keep that air from being drawn into that pump. Whatever, anything that you can do. I've even, you know, in some cases I've taken my helmet off and just set it over the top of that whirlpool if it to seal it off so that we're not drawing any air into the pump. But it's so much, you know, it works so much better if we just have some kind of a piece of something that'll float and float right over the top of that, and it just keeps that whirlpool from causing any air to be drawn in through the drafting line. As far as safety considerations, we want to try to set this up where we don't have to back that apparatus in any more than we absolutely have to. Now, like I say, some apparatus are set up where that's the way they dump. And if we do that, that's fine. We just have to make sure the operator understands where he's going to back into. Matter of fact, I've had guys who will set a, once they've dumped, they'll set a cone where they know it's right there by the door. And every time they come back, they know exactly where to stop when they back in. We don't ever want to get anybody between the apparatus and the dump tank, ever. We want to keep, you know, we want to back them in. If you're guiding them in, just be on the side. Don't ever get between, you know, wait until, matter of fact, if it's a rear dump and you've got a lever back there that you've got to release to dump that, don't ever get on that apparatus until you hear the air brakes are set. We want to, you know, things can get slick around there because we're splashing water and so forth, especially in the wintertime. So there's a possibility of slips, trips, and fall hazards. Just be cautious of those. It could be that we need to get some sand or something like that to a scene in the wintertime to lay down so that we don't have those icing situations. The other thing I feel is very important, we don't really have it listed here, but I don't like to see the apparatus operator, driver, leave the seat. I think that they ought to stay in the tender. I know sometimes we're shorthanded and they've got to open their own dumps and so forth, if it's manual open on the back and so forth. But possibly if we could get a rider to go with them or have someone that opens those up for them at the scene, at the dump site, and somebody to hook up the hoses at the fill site, it just adds to the efficiency. And it's also, I think, a safety issue that driver stays behind the wheel the whole time. And the other thing we have to watch out is for civilian traffic. We need to wear, you know, high visibility apparel and that kind of thing if we're anywhere near a roadway, because, you know, people like to watch what we do, and they're going to be driving by more than likely. Okay, as far as efficiency at the dump site, again, we want to set the dump site up where we can drive through, if at all possible, little backing. You know, how many tenders can we dump at once? And this has to do with the configuration that we set up. We'll talk a little bit about that in a minute here. How many, we want to look at what kind of flow rates we need and what we're getting and the capacity of the tenders that we're utilizing. This is kind of why it's important to possibly even have a legal pad there and write down, you know, this certain fire district has brought this truck and this is their capacity and so forth. And it kind of gives us an idea of what's on the road, what's coming, or what's been there, that kind of thing. We want to position so that those multiple tenders can offload at the same time. If you've got one that's able to or has to back in and one that side dumps, then maybe you can send the one that backs in to the very end of an inline setup, and he can dump there while the one that side dumps is actually dumping right off the side, pulling up right alongside that inline setup. Multiple dump tanks. I'm a big proponent of multiple dump tanks, unless it's just, you know, you go to a fire and you're just basically there trying to, you know, it's all, whatever it is already burned down. You're just trying to cool it or something like that. Because you for sure have plenty of water if you've got multiple dump tanks set up, and you're also able to dump more tenders and get them back on the road and get them in that rotation. It also gives your pumper, you know, a larger reserve if needed. The disadvantage, you've got a larger footprint, and you have to look at that. And here again, that's one of those things in the first setup that you've got to look at is how can we get this in here and still be efficient. It does take a little longer to set it up, and you do have to kind of plan it out a little bit. And it requires a little bit more equipment because you do have to have jet siphons and that kind of thing to transfer that water from one tank to another. When we look at the dump site, you know, single tank set up here on the left, you know, if you think you can handle it with a single dump tank, you know, there you go. One tank, you're drafting, you're dumping, and then you're drafting. You may set them up in line like these right here. I think there's 4 or 5 tanks set there, and gives you multiple points to dump. It gives them a good place to pull up along the side, and they can dump into whichever tank that needs to be refilled. One of the setups that I really like is the diamond layout, like on the right-hand side here, because it gives you multiple places that you can dump. You can dump off, you can even dump in the corners here if you need to, but it gives you places that you can set up, and if they have to back in, you could even have people back in. If you've got a large enough area, you could have them back in from 2 different areas, this side and so forth. If you're dealing with issues with narrow roads and having to set up, one of the things that's come out here in the last few years is the narrow tanks. They have the same capacity, but they're long and narrow so that you don't take up any more of that extra lane. It's just something to look at if you're replacing a dump tank. You might want to look at that. They fold up to the same size. They have the same capacities. They're just long and narrow as opposed to being a square. With the jet siphon, you know, we just use it to transfer water from one tank to another. We put it on the hard suction and just push that water over the edge. It uses a Venturi principle. We typically hope that it's going to move up to about 600 gallons per minute, transferring from one tank to the other. One of the things to look at if you're on your drafting side is, you know, some departments only carry a barrel strainer, some carry both. If at all possible, if you can get a low level strainer, like the one up here on this side right here, some work that Denny Wilson did a few years ago at Fire College, I believe, you can get that water level down to within 2 inches of the bottom of that tank. Now, on a 3,000 gallon tank, that means that you're only leaving, you're able to draft down to about where you're only leaving about 277 gallons left in that tank. With the barrel strainer, you start having issues at about 12 inches, which leaves about 1,680 gallons of water in that tank that's really not usable. So if we can get that low level strainer in the tank that we're actually drafting off of, it actually gives us about 1,400 gallons of extra water, you know, to be able to utilize. And there's 2 places that this will work out really well. One is at the beginning of the incident, where we may not have all those tenders in that mobile operation yet. They're still en route, or at the very end where we've actually able to send some of them home and utilize all the water that they've actually brought to the scene. If you're limited on manpower, I've seen this in operation. I know talked to some different chiefs that have these. This is just something that's out there and available. It's called a holly tube. And the thing that's unique about these is they're kind of a one-man operation to set up. With the hard suction, it's cumbersome to deal with and so forth, where these are pretty light, and you can just, as you can see, you can take this angle iron right here and it just sets over the edge and you just push water over there. Capacity on these, the one that's 6 inch and it's set up for 1.5 inch line to transfer that water will transfer about 800 to 1,400 gallons of water per minute. The 8-inch tube that's set up for a 2.5 will transfer 1,400 to 1,700 gallons per minute. So you don't lose anything, and all you're interested in is you're just interested in getting that water over from this edge of this tank to the edge of this tank. And from what I understand, if you don't watch the pressure, you'll actually blow water over the edge of the tank on the other side. So it really works on lower pressures and seems to be a real handy tool, especially, like I say, if you're low on manpower and somebody's having to set these up, 1 or 2 guys having to set them up at a time. The other thing you might want to consider is the rural hitch. This is something we bring up. Now this is kind of a relay pumping type situation. You've got a long narrow driveway here. You've either got this Quonset building on fire or you've got the house on fire at the end of this lane. There's nowhere to turn around there, so you're going to be backing into this lane every time. And the situation there is if it's wet and you're backing down that lane and make a little mistake, the driver makes a little mistake and gets off the edge and gets stuck, our water operation is over. So we would lay 5-inch or something like the any LDH down that lane and set our operation up out here at the main road and then relay pump to the attack pumper up here. It would be, I think, a really efficient way of doing it. And I'll tell you another place that works. This is a map of an area around a lake area that we service in our response area. And every place that there's a circle here, there's a rather large home. But the thing that you're going to find is these are very narrow roads back in here. And this is where we can utilize this rural hitch type system. We're bringing water in. This is the main road up here. We're bringing water in. We could either set up a operation here and have the attack pumper lay into it there, or possibly here, because there is a turnaround here, and it would still, you know, it's not as easy to get back in here, but there is a place that the tender could turn around and go back out, and we can hold those other tenders right here until he gets back out. But these long winding driveways is another place that works very, very well. Just for information, there's some other options as far as tanks. This is the frame tank that we normally think about as a dump tank, but there are others out there. There's a frameless tank. I've seen these in operation. Not a big fan, but they do work. Then there's the roll-up tank, which actually has a frame that breaks down and it's all goes into a bag, and you just have to put the frame together, and then it's a supporting frame that goes on the inside of this tank. And then the other thing that we see utilized from time to time, and especially, like I say, on maybe a room and contents fire or something like that, is just setting a stationary large tender and just nursing that attack apparatus off of that and so forth. And I know a couple of districts that have used these for years, that situation for years, and it works very, very well. But you get into a large fire, you're going to have to put down multiple tanks, and you're going to have to put this piece of apparatus to work hauling water. Okay, as far as pre-planning, we want to identify the water supply concerns before the incident starts, and that's very important. We want to take some of that workload off of the incident commander. We want to know what our mutual aid needs are going to be before we really need them. I mean, that's very important. And one of the things that we really, really support is automatic aid. We do a class called Fires on the Farm, and one of the main things we talk about there is having automatic aid agreements. You know, we're all shorthanded usually, and we need to look and see where this gets that water on the road a lot quicker. You don't have to, the incident commander doesn't have to call for the people he needs. It's already pre-set up, and it just adds to that efficiency. We have to identify the fire flow that we need. Have we got some high-risk occupancies that may need a greater flow? Do we have some fire loads that are going to be outside that water loop that need a greater flow, that kind of thing. Then we all want to identify those water sources that we can use and see how they fit into the amount of water and fire flow that we need. And we also want to get out there, if it's something where we're going to be using a private water source, we want to make sure that we have the permissions needed before we actually need to utilize them. When we look at flows, we're looking at the first 10 minutes, we typically think of about a 250 gallon per minute flow. Buildings without exposures, we're looking at about 2,000 gallons is what we would be putting into our pre-planned. Buildings with exposures, we're looking at about 3,000 gallons per minute. For sustained operations, we're looking at a flow of about 250 gallons per minute, maybe 500 gallons per minute. Depends on the occupancy. It depends on the type of construction that we're dealing with, the building size, that kind of thing, and what kind of exposures have we got. What other buildings could become involved. When we look at the availability of water, what can we sustain for a couple of hours? 250 gallons per minute, that's about 30,000 gallons of flow. If we're looking at a 500 gallon per minute flow, we're looking at 60,000 gallons of water that would be needed. So when we're looking at these static water sources, what can they supply us? When we look at the NFA formula for figuring this, and this is where we can this is something we want to do in pre-planning. We've got a 30 by 50 structure. It's 50% involved. So when we plug that in, we're looking at putting the length times the width, divide it by 3, and then multiply that by the percent of involvement. And so what that would actually give us would be, in this particular scenario, we'd need about a 250 gallon per minute flow. We take the 30 by 50, we multiply it, and then divide it by 3, and then multiply it by the 50% involved, giving us that 250 gallon per minute flow that we would need. And we're talking about usually at least 10 minutes. When we look at the Iowa formula, now the Iowa formula does not take in consideration a percent of involvement. And I actually use this one more often because it's got a bigger fudge factor as far as when I'm pre-planning. If I look at this, I get an idea of how big the building is, and it's going to give me, if I know that I can get this flow going, I know that I'm going to have the right amount of water there. So if we take a building that is, that's 40 by 60 by 30 foot high, and we multiply that out, divide it by 100, that gives us if this building was fully involved, we'd need a 720 gallon per minute flow. We look at the number of tenders we're talking about getting 8 tenders on the road. So, okay, as far as determining how much the tender can supply, because they are different, they are made differently. As far as continuous flow, it's based on how quickly they can dump, how quickly they can refill, and what the travel time is. And we can do that estimate using the formula that you see here. We take the tank capacity minus 10%, and then we divide that by the load, the dump, and the round trip travel time. And again, the rule of thumb is we want to get at least 100 gallons per minute per tender. So if we look at this particular tender here, I went online and found one with some of the capacities and so forth. This is a 3,000 gallon capacity. We're going to say that it will fill in 4 minutes. It will dump in 3, and the travel time for this is about 11 minutes. We plug that in, so we've got the capacity minus 10% plus fill, dump, and travel time. This is going to give us about 150 gallon per minute flow. Like I say, 3,000 minus 10 is 3, I'm sorry, in other words, we're taking away 300 gallons, so it's 2,700 gallons, and we plug that in, we're getting about 150 gallon per minute flow. Okay, as far as static water sources, We have to determine the usable depth. And then when we look at a pond, a lake, a stream, whatever, we have to look at what we can get. And the thing we're looking at is, can we get to the edge? Can we get at least 2 foot of clear water space around it, around that strainer? You know, if we can get, say, 10 foot of hard suction in there, 2 foot around the water edge inlet, we've got about 5 foot of usable water. One of the things that they've included in this program, and it is a possibility. I always caution people a little bit about using private pools, private water sources, but especially private pools. But if we figured this pool right here, you know, it's 10 foot by 20 foot, it's 4 foot usable depth, we're going to get about 6,000 gallons of water out of that pool if we were using it for a source. Now, my issue with using private pools is there's some liability involved. Who's going to pay to refill it? What happens when we pull up, let's say we don't have a portable pump, and so we pull up to the edge of it and the weight of our pumper damages the concrete? Who's going to pay for that and that kind of thing? So that can be an issue. So I do caution you about the liability in using private water sources. In this particular case, this is a round pool. It's 24 foot. It has 4 foot of usable water. It's got about a 12,000 gallon capacity as far as usable water for us. But again, just be cautious using these private water sources. If we're looking at a creek or a river, that kind of thing, we can look at the flow. Here in this particular example, it's 5 foot wide. It's got a 20 foot per minute flow. The usable water depth is about 3 feet. So we're going to get about 2,250 gallons per minute coming down this particular water stream. So that would not be a bad water source if we can get up to it.
Bill, I got a question for you.
Yeah, go ahead.
I got a couple things for you. We just want to reiterate all the formulas Bill is going over are available at the IFSI website. I know I've received a couple questions on that, figuring out if you really needed to fly and write or type these formulas out. So we learned that as of last class. You guys wanted the formulas, so they are at our website. So please go there and you can get the formulas from there. I got a question from Jesse. How about using portable pumps at static water sources? Is that something we can do or something we want to steer away from?
No, absolutely. Matter of fact, in the scenario that you remember the map I showed you where we were setting up possibly the rural hitch, we can go to, in that case, in that particular case, we can put a portable pump. We've got a 750 gallon per minute portable pump, and we could put it at the water's edge and flow water, and you got your choice. You can either have it flow into a dump tank and draft off of it, or you can use it directly on lines. My choice would probably be the dump tank and then draft, because you can adjust the pressure on different lines and so forth so much easier. But yeah, that is an excellent way to do it. Either that or a floating pump, either one would work very, very well.
Perfect. Thanks, Bill.
Okay. Again, practice makes perfect, guys. If you are in a situation where you're using mobile water operations, it's just a good thing whether you do it, you know, quarterly, once a year, I don't care, preferably a little more than that, but just pick a night and set up where you actually set up a mobile water operation with all of the mutual aid departments that you deal with, and make sure that everybody's got the right fittings. Make sure they're on the, you know, you've got the right ones on the right end of the hose or the right end of the truck, that kind of thing. Look for, you know, don't look necessarily for problems, but look for ways to make it more efficient so that we can do a better job hauling water to the scene. You know, moving that water is essential. You are the lifeline, or the water line, I should say, for that firefighting operation. And again, practice never hurts. You know, it's where we find out in training what the problems may be, so we don't find out on the fire scene. Lastly, it's not NASCAR, and we don't lap and we don't bump draft. There's nobody gets a trophy at the end of the incident for the most water hauls. So, or at least I've never seen one handed out. So listen to your water supply officer, keep things moving. He's going to try to move it as efficiently as possible. And that's the whole idea, is efficiency as much as we possibly can. If you have any questions later on, my email address is on the screen here. My cell number is right there. You can text or call me. If you call me, leave a message, please, because I do operate equipment and sometimes I don't feel the phone or hear it ring and so forth. So I will get back to you just as soon as possible, and we'll try to get that question answered if we possibly can. Or if I can't answer it, I'll try to find you an answer. Okay, Tim, that's
Perfect. Corey just brought up a good point. He talked about when you're using a pool or another tank in a yard to watch out for septic tanks, old cisterns. So
absolutely.
most of the time you're going to have to drive your tenders or pumpers up to a pool and you got to go through a yard. So that's other things to be concerned with. Very good point, Corey.
Absolutely.
Bill, I want to thank you for the job that you did. Another great job in talking about rural water. For everyone, once again, the formulas Bill went over are located at the IFSI website. And once again, a couple more points for you. The CEQs, they should have been sent out to your emails. Please fill those out. Let us know what you like, what you didn't like, things that we can approve, and we'll try to make that happen. And if you're watching this as a group in your fire department, please have your training officers or fire chiefs submit a full roster with everybody's full name to the Institute, and we will get you a certificate of attendance. Okay. Once again, we got more classes coming up. Next class will be Fireground Search and Rescue, which will be on June 8th in the evening from 6 to 8, and June 13th from 10 to 12. And good news for us, all the regional reps have been given the go-ahead to start rescheduling Cornerstone classes as of July 1. So if you are wanting a Cornerstone class, please get a hold of your regional reps, and we will try to get you squared away and try to get some classes coming your way. So we'll stay online for a few more minutes, answering questions. If you have any, please use the question and answer box at the bottom of the screen, and we'll make Bill stay on here a little bit longer and answer any questions we have. So thank you guys. Enjoy your Saturday. Thanks for taking an hour and a half out of your day, and hopefully you learned something. Thanks. This is where we get to stare at each other.
Yeah, we get to stare at each other.
So Bill, we'll hang out for a few more minutes. I don't see any more questions coming up yet.
Okay.
So if we have no more questions within the next few seconds, we'll go ahead and sign off of here and enjoy your day.
Okay.
Thank you, Mr.